Good morning. So today's lesson continues what we were talking about last time about artificial intelligence. I think that should say AI rather than A1. I think that's a mistake. So building on what we're learning about machine learning and robotics. So we need to make sure that we understand what bias is so that we can then understand algorithmic bias and give examples and case studies and understand and debate and discuss all of these so that we have a really good understanding of the advantages and the disadvantages of these technologies. What do we mean by these technologies? Artificial intelligence, machine learning, and robotics. So we know that we are not always right, and we know that we can write code that is not always right. So it makes sense to assume that the code that we write is not always right. But it is possible to write perfect code that produces perfect output all of the time. But when I say perfect, I mean it does what it's told to do rather than what it should do. But when you start adding in uncertainty to do with artificial intelligence, it's not just a system of if statements. It doesn't say if and then it has a very clear flowchart to make its decisions. There is some element of uncertainty there. So we cannot rely on what the computer says. And especially when big decisions are built upon these decisions, as in life and death decisions to do with military drones, it becomes very, very scary. We need to be able to find out when computers get things right and when they get things wrong. So let's talk about an algorithm. Precise set of instructions for solving a particular problem. So we've learned this as step-by-step instructions to solve a problem. I like this word precise because it is very clear how to solve a problem. It doesn't have to be to do with a computer. It can be a precise set of instructions for how to make a pizza, but we have a problem, and can that problem be solved? We talk about bias, and you'll do this in English and geography and history, and it's the same kind of thing. It's where you tend to be a bit kinder to some people than other people. Maybe you have a bias towards being more friendly to people who wear a particular sports brand or a particular type of jewelry or a particular skin color or something like that. Humans can be biased, but so can computers. So algorithmic bias is where the behavior in a computer program has unfair outcomes. Remember, we talked about training data last lesson. You, as a human being, learn from what you perceive. You have your 5 senses, and as a baby, as a toddler, as a child, as a young adult, you perceive the world around you, and you make your choices based on that data. It's the same for a computer. If the data going into the computer is good, then the artificial intelligence can make fairly unbiased decisions. But if we provide biased data in the decisions that the artificial intelligence makes, it should be no surprise that that's biased decisions as well. So at the moment, this is not an exhaustive list, but Mr. Walsh showed me a BBC News article where Google used, I think it was in Google Photos, to automatically categorize images to save you time searching for stuff. So you take a picture, automatically uploads it to Google Photos, and then you can search for like holiday snaps or food, and it will automatically find it. Problem was that it incorrectly and racistly, unfairly categorized black faces as gorillas, which was absolutely outrageous. Now, Google tried to correct it, but all they did was they removed that particular category from their artificial intelligence. They had trained it with biased data. It made unfair and racist decisions because of the training data going in. And you'll look at some case studies of how its artificial intelligence has been discriminating against women as well. So there are 3 reasons here. One is if there are human beings in charge of saying, like supervised learning, we learned about that last time, supervised learning, if the humans say that this is what you should decide, and the humans are biased, then the computer's going to learn that bias from the humans. Or it could be that, like this is often the case, I think it was Facebook's facial recognition or maybe Google's face unlock code or Apple's unlock code. I'm not entirely sure. But if you were Asian, then it was easier to fake your Face ID because there was a smaller training set used with Asian faces. Whereas if you were white, then your Face ID was more secure because there were more faces used to train it up. And it's because of inaccurate or insufficient training data. Or it could be non-aspirational training data sets. For example, if you if you search in engineer on Google Images, most of the pictures that come up certainly used to be pictures of white male of a certain age, which means that if artificial intelligence was going to learn from that, it would discriminate against young female potential employees. So there are benefits. You can use this for image recognition, but we have to be aware of the downsides too. We're now at a point where analyzing X-rays is more accurate down to computer vision and artificial intelligence, as in you're more likely to spot a tumor if it's analyzed by artificial intelligence. There's going to be less of a delay. You don't have to wait for weeks for a specialist or radiographer to see it. Artificial intelligence can do it instantly and diagnose more accurately. Not 100% accurately, but more accurately than human beings. Speech recognition and then also translation. So this is great for people who have particular disabilities. There's an amazing story in the news at the moment about someone with locked-in syndrome who can't move a muscle, can't move their eyes, can't speak. That person's sister has been looking after him, and the man has just been able to say thank you thanks to a brain implant and artificial intelligence. It takes him a couple of minutes to write a sentence, but the artificial intelligence can scan his brain, and he's worked out how to train it so that he can now communicate, even though he's got locked-in syndrome. Absolutely phenomenal. And we talked about medical diagnosis and designing treatments. Disaster recovery. So you can give satellite data to artificial intelligence. It will learn where the people are most likely to be, and it means that you can prioritize your disaster relief efforts based on that data to save people's lives. Save the people's lives who are trapped by a volcanic eruption, and save the lives of the people, the first responders who are going in, because you can spot the potential dangers. There are all sorts here. So financial advantages. I'll just put these on. I'm not going to talk through all of them. But you know there are advantages. By the end of today's lesson, you should be able to talk about them. And we've talked about the difficulty of bias. Last lesson, we talked about the fact that artificial intelligence might be coming after low-paid, low-skilled jobs. But we also said artificial intelligence is beginning to creep into high-paid, high-skilled jobs as well, like GPT-3, a new open AI algorithm where you can say, build me a first-person shooter, a 3D game where you can avoid obstacles. And that's it. You say it. It uses artificial intelligence to do speech recognition, so you can see the speech. And then it uses natural language processing to understand the speech, again, using artificial intelligence. And then it uses artificial intelligence looking at all the code submitted to GitHub at other first-person shooters and 3D games to do code synthesis. It will write the code for you, and you instantly get the game that you've asked for. Incredible. But it's replacing high-paid, high-skilled jobs with artificial intelligence. And then at the moment, there was a tragic plane crash in China last week. And whenever there's a plane crash, you search for the black box recorder so you can find out what happened. And the plane just dived, a vertical dive, and the black box recorded the accelerometer data. And you can use that data to work out, well, who's at fault? Did the pilot just fall asleep? Like, what happened? Was there a machine failure or a human failure? But if it's self-drive and the artificial intelligence is in charge, well, can you actually work out who was at fault there? So the big news at the moment is I think it's Mercedes has said for the first time that if their autonomous vehicles are fully in charge of their Mercedes vehicles, then they take liability for any accidents, which is huge. It's going to transform self-driving cars across the planet because now there's some clarity about who is to blame. It's not the driver anymore, it's the manufacturer, thanks to the proven safety record of their artificial intelligence systems. But if it's semi-autonomous, where you've got a human being and you've got a kind of almost self-driving car, we've got this big push from the government at the moment about, you're not allowed to use a smartphone rightly when you're driving, but you're not allowed to use a smartphone if you're supervising Tesla's self-drive, because you are still liable, as in you're the one who's going to get blamed if your car runs somebody over. So we're in this blurry area of who's to blame if things go wrong. So there are laws to find out who is at fault. And if you work for a software company or a hardware company, they will have an army of software engineers, an army of hardware engineers, probably even more lawyers, because they need to make sure they know the regulatory frameworks, not just in their country, but around the world. And obviously we're governed by UK law, and it's a growing sphere of influence for lawyers. And in reality, it's just a blurry, murky area. And in law, we don't like blurry, murky areas. So there's all sorts of research. I'm not going to read through all of this, but there's all sorts of research going on and legal precedent. The law works with case law and precedent, as in you have a specific law and then you find out, well, how's that law been interpreted in the past? Some of you will be lawyers fighting to represent big companies so that they don't have to pay out when their self-driving car has just run someone over. Some of you might be lawyers representing people who've just been shot by a semi-autonomous toaster who's tried to take over the world. Who knows? But there's going to be a growth market in the software and in the hardware and in the law. So let's have a look and see where we're up to so far. I'm sure I opened the Word document. Can't see where it is. I'm going to pause the video whilst we watch this. I'll show it like side by side. If you're catching up from home, then you'll just need to watch the video yourself. Okay, so let's move on to activity 2. You can chat with the person next to you as we work through this. I will give you 10 minutes to try and get through as many as you can. I'd like you to discuss with the person next to you and fill out the table. If you go to this link, you'll find some case studies. So these are case studies of artificial intelligence that have demonstrated bias, as in they're not nuanced, they're not fair. They inherit their bias from either the developer or the training data or the scenario or the situation. So read up about them, explain what it's used for, how was it biased, how was it unfair, why was it unfair, and what happened as a result. So we've been discussing activity 2 in class. I think there's some fascinating and horrifying case studies here, but we're not going to discuss them in the video. I'd like to move on to activity 3, where you have to do a little bit of research and say, are we currently at a place where things are more accurate than humans? And I said this lesson that yes, it is now. We are now at the stage where computer vision can analyze X-rays and spot cancer more quickly, definitely, and more accurately than even well-trained radiographers. Can it process more data in the same time as a human? Yes, it is much faster, has more capacity to do it than humans, which saves a huge amount of time, a huge amount of money, and as a knock-on result of that, can save lives. Can it take action more quickly than humans? Well, at the moment, if you identify cancerous cells, it's not a completely automated process. You still have to wait for surgery, and most cancer surgery is still done by human surgeons. Maybe not for that long in the future. Brain surgery can be autonomous at the moment, but not always. Can it free humans from danger? Well, it doesn't eliminate the danger. There's still danger in the process, but perhaps it reduces the danger. So you go through and you rate where you think we're up to at the moment. Just put in a yes in each box. Okay, whilst you're working on that, I'm just going to give you an example of what you can do as your extension. I'm going to search for a Google Teachable Machine, and we're going to get started with this. I think I showed you this before. I'm going to make an image project. I would love to be better at foraging. I would like to find out about mushrooms. Mushrooms are delicious. I love a mushroom omelette. Sadly, mushrooms can be poisonous. I don't know which mushrooms are poisonous, and I don't know which ones are delicious. So wouldn't it be a good idea if I could use artificial intelligence to find out which mushrooms I can eat? What could possibly go wrong? Well, let's find out, shall we? Google Images. I'm going to find some pictures of edible mushrooms. Don't try this at home. Edible mushrooms. As in, feel free to try what I'm doing for the artificial intelligence at home, but please don't risk your life on this. So apparently these are edible mushrooms. I will save the picture I'll make a folder somewhere. Pictures, make a new folder for AI training. And let's make a new folder for edible mushrooms. And I'm just going to number them. It looks like that website has lots of pictures. That's nice. Have I got that one? Right click, save as image. Yeah. I think I want to save it as a JPEG, not a WebP, but I don't know if it'll work. Save image as. Dear, all of these are WebPs. I don't know if this is going to work. I think I've got that one already. Maybe I should go back to Google Images. There we go. Apparently that one is edible. I'm not trying to. There we go. And then I should be able to train my data set. Let's upload some images. There we go. Can I get all of those? Choose the images, paste in that. Oh no, it can only find JPEGs. Can it also do WebP images? No. I have to make sure they're JPEGs. That's irritating. There we go. That's a JPEG. No, it's different. No, it's exactly the same one. Come on, edible mushrooms. See, if my data set is tiny, then my artificial intelligence is going to be rubbish. The more pictures I have, the better, the more accurate my artificial intelligence model is going to be. Which means that if I'm putting my life in its hands, which I'm not, by the way, there we go. Let's upload some more images. There we go. I've got 5, even though 2 of them are the same. Come on. Is that an edible mushroom? Ugh, I wouldn't eat that. But apparently. There we go. And then we should have dangerous, poisonous. Let's find some poisonous mushrooms. Never trust the internet with your life. Well, I hope I'm illustrating a point. It's possible to train AI to do this. Doesn't mean it's a good idea. A death cap mushroom. Clues in the name, everybody. If it's light blue, am I going to eat it? No. Mushrooms can kill dogs. Oh dear. Don't want that. Apparently, that one's poisonous. It's a WebP, so I can't learn from that. So this one's an interesting one. Will it actually learn from the image, or will it just recognize that there's a watermark on it and think that that's a poisonous symbol? There we go. That's obviously poisonous because it's got a poisonous symbol on it. But will it learn from the image, or will it just learn from the fact that the image is smaller? We don't know. It has no common sense. It just learns from the data it is given. So what happens if your technician, the person you're paying to train all the data, gets it wrong and mixes up your data set? Well, then your artificial intelligence is going to be all mixed up as well. But I'm keen to find out, what type of mushroom am I? If I turn on the webcam and give it my face, am I a poisonous mushroom or an edible mushroom? Let's find out. The suspense, I won't say is killing me. It's a bit too close for comfort. Here we go. Switch on the webcam. That's me. I'm edible. But I don't know how I can make it if it's just a... Oh, it's not quite sure. Let's find a picture of a poisonous mushroom that we haven't had so far. This one. There we go. The most common poisonous mushroom. Let's call it test. Give it an image. Will it correctly identify it? Come on, test. Oh yeah, nice. I'm not going to eat it. Jolly good. Let's give it another poisonous one, shall we? Ugh, yuck. Not going to eat it. Test 2. Yeah, I will pick one that's not bright coloured. Let's see. There we go. One that looks like I might be tempted to eat it. So that one. There we go. Possibly. It looks suspiciously like one in my other training set. Oh, it's a J5. Test 3.jpg. Let's pretend it's a JPEG and hope for the best. Oh dear. I'm going to eat this one and I would die a horrible, slow, painful death. So you can see the point here. Your artificial intelligence is intelligent, but it's only as intelligent as the training data you give it. If you give it more data, you have to be careful that your data is fair, it's nuanced, it's unbiased. Otherwise, the decisions your artificial intelligence makes may well have unintended consequences. Okay, so you need to make sure that you've read through all of these case studies, you've filled it in, you've saved it, and you've uploaded it to half term 10, please. I think it's computing 3 or something like that on the VLE, I'll check. So here we go, this is where I'd like you to upload it to, half term 10, issues and impact 3, please. And if you wanted to try this for yourself, it's Teachable Machine is what you search for, Teachable Machine with google.com.